going to look at the Chapter 6 SPSS exercises. So in the first question, we need to create a histogram for age with a superimposed normal curve. We're going to analyze how does the distribution of age deviate from the theoretical normal curve. Okay, so in order to make a histogram in SPSS, we go up to Graphs, Legacy Dialog, Histogram. We put our variable age here, and then we click this box, Display the normal curve, and that will superimpose the normal curve onto our histogram. We click OK, and here's our output. So now you have to answer the question, how does this histogram deviate from the normal curve? Next part of this question, they want us to calculate the mean and standard deviation for age in this sample using either the frequencies or descriptive procedure. So we go into SPSS, we go up to Analyze, Descriptive Statistics, Descriptives. Let's find our variable age, throw it over here into the variables category, and click OK. And this will give us our mean and our standard deviation. The next part of the question says, assuming the distribution of age is normal, calculate the number of people who should be 25 years of age or less. So in order to do this, you're going to want to calculate your z-score. And in order to do that, your z-score is equal to your score minus the mean divided by the standard deviation. So when you do that, you take that z-score and you go to the table, Appendix B in the back of your book, and you find the area underneath the curve, and then that will give you the percentage of people in this sample who should be 25 years of age or less. The next part of the question says, use the frequencies procedure to construct a table of the percentages of cases at each value of age. And then you can compare that calculation you did in C with the actual distribution of age in the sample. And then you answer the questions, what percentages of people are in the sample are 25 years old or less, and is this value close to what you calculated, and why might there be a discrepancy? So in order to do that, we go over here to Descriptive Statistics, Frequencies, we find our variable age, and then we click OK. And this will give us the chart we need. So we go over here to 25, and it'll say in our cumulative percentage columns 8.4. Now we're going to compare that cumulative percentage we get from this table with the answer we got in C in order to answer the questions in D. Question 2. So we can use SPSS to calculate standard scores or z-scores for any distribution. So we're going to examine the distribution of education, or years of school completed. So the first step is we want to take SPSS and use it to calculate all the z-scores for all the people in the sample for the variable education. In order to have SPSS calculate all the z-scores, we can go up to Analyze, Descriptive Statistics, Descriptives. We find our variable, which in this case will be educ. Throw that over here. Click this box that says Save Standardized Values as Variables. Then we click OK. Now SPSS is going to spit out this output, and it isn't going to spit out all the z-scores. What actually happens is it saves all the z-scores as a variable, and you can find that by going into Variable View and then scrolling down, and here it is at the bottom in row 52, z educ. So these are all the z-scores for the variable educ. The next part of the question is, what is the equivalent z-score for someone who has completed 18 years of education? In order to find that, we can come up here, and in our variable view, we can look for the variable educ, and we can run descriptive statistics. Now if we look here on this chart, 18 is the third to last highest year of school completed here. So if we slide this over a little bit, we come down here to educ, we can run descriptive statistics again, and if we go down to here, we count up 3, we find that our z-score is 1.5547. So this is your corresponding z-score for 18 years of education. You could do it by hand by calculating the z equals the score minus the mean over standard deviation, but because these are all ordered in SPSS, we can just use SPSS to do it a little faster for us. C asks us to use the frequencies procedure to find the percentile rank for a score of 18. So if we go back to SPSS, here's our output. This is the z-scores that we just created, but if we scroll back up here to our frequencies, we can go over to 18, and we can find that the cumulative percentile column tells us that answer for that is 94.8. Part D asks us, does the percentile rank that you found from the frequencies correspond to the z-score for a value of 18? In other words, is the distribution of years of education normal? If so, then the z-score that SPSS calculates should be very close after transforming it into an appropriate area to the percentile rank for the same score. So let's go ahead and look at that. If we go back down to the z-score table that we made, if we go to the corresponding column with 18, which is 1.45547, we find that it too has a percentile rank of 94.8. So we can see that the distribution is normal, because the percentile rank for 18 and the corresponding z-score are exactly the same. This part of this question asks us to create histograms for both educ and the new variable zeduc and explain why they have the same shape. So if we come up here to Graphs, Legacy Dialogues, Histogram, we can look for educ and click OK. This will spit out a histogram for us. And then we can go to Graphs, Legacy Dialogues, Histogram, get rid of that, and find zeduc. Click OK. And now we just compare the two histograms. So for the last question, we're going to repeat the procedure we just did in problem 2, but this time we're going to run separate analysis for men versus women, and then we're going to do blacks versus whites, based on the variable education. We could run the separate analyses by using the data split file command. So we go to SPSS, we go to data split file, and we find the variable we're going to split it by. So let's start out with sex first. We organize output by groups, put in sex into that column, and click OK. Now SPSS will do its job. So we go to Analyze, Descriptive Statistics, Descriptives. We find our variable, which is education, or educ. Throw it over here in the variables column. Click on Save Standardized Values as Variables, because remember, we still want those z-scores. Then we click OK. So that's going to split the data. Here we have respondent sex equals male and respondent sex equals female. So if we go down here to Variable View, we can get our z-scores split for education, but split by males and females. And we can see that by right-clicking and then viewing our descriptive statistics. So here's our z-scores for males and our z-scores for females. So if we want to split the data by race, we go to Split File, and we find our race variable, which is race N1. Organize output by groups. We click OK. SPS will do its thing. Then we analyze descriptive statistics. We look for our variable education. And remember to save the standardized values as variables because we want those z-scores. And then this will spit out our data for us. So we're interested in whites and blacks. Now if we want to look at the z-scores, we can go back here and we can run descriptive statistics, and this will show us our descriptive statistics for the different races. So here it is for white, and here it is for black or African American. So you're going to use this data you just collected in order to answer the questions: is there a difference in education among men, women, and blacks, whites in the GSS sample? And how would you describe the distribution of educ for the 4 groups? Now, if you want to get a visual picture of the distribution, you could run a histogram for each one of those 4 groups, and that would give you a visual picture. And if you remember back to question 2 where we made histograms, you just go to graphs, legacy dialogues, histograms, select your variable, and that'll produce your output. Again, thanks for watching. Here are my office hours, and if you have any questions, you can either get in contact with me via email or text, or talk to Dr. Case. Thank you.